Hi, in today's video I want to cover a few hardest past paper integration questions that I could find on Revision Village around 4.5 to 5 rated, the level. I will share my math tricks and thought processes, so it's best for past preparation and knowing how to tackle these challenging problems without being too nervous. So the first question is a paper 1 question. So we have a graph, and given that this curve passes through the point p comma 0, we want to state the value of p. State means that we just give the value without needing to show steps. So by observing this, we know that to make y equal to 0, we can have either x equal to 0, or we can have ln x equal to 0. To make ln x equal to 0, we simply need ln 1, right? And since p is to the right of 0, then p just needs to be 1. And here we go. So this is a really simple 1-mark question. So now we have a region R enclosed by the curve, like this curve, from P to E, so that's from 1 to E. And the x-axis and the line x equals to E. So here is x equals to E. I just drew this line. So R is this kind of a triangular region enclosed, and we want to find the area of this region, and the question kindly told us to integrate by parts twice. So this is for C, part C, so don't get confused. So this is not for part B. So for part B, we gotta write it out on our own, the integral. So we have, since p equals to 1, we have from 1 to E, and then we have this integral of this original function, dx. And so we want to do the first time of the integration by parts right now. And so we use integration by parts when we have like a product of functions, right? Now we have x times ln x to the power of 2. So we gotta set 1 to be u and 1 to be dv, right? And remember the rule called ILATE? And this is inverse trig, this is log, this is algebraic, this is trig, and this is exponential. So here we have ln x here and x is here, so we should set ln x to the power of 2 equal to u, and x is just dv over dx. And since we are doing integration by parts, we should also find v by taking the integral of x, and find du dx by taking the derivative of this. Is just really basic skills. And then, so remember we have, so that's u dv, this equals to uv minus v du, right? So we just gotta copy this just as this, and then write this part as the thing next to it. So now we have uv, which is just this thing times this thing simplified into this fraction. And we also gotta have 1 and e here. So remember, it's not just for the integrals, so every part of this equation gotta have like the function for e minus the function for 1. So like we gotta include that for all of them. And we have the integral from 1 to e for v times du, which is just this times this. However, this is really simple because we just need to substitute and subtract, right? However, this thing is still bothering us because we also gotta do integration by parts here again, since we have x times ln x, so that's a product. We gotta do that integration by parts again. So I use some different variables this time. So x, I made it dA over dx, and ln x is b. So a equals to the integral of this, and db over dx is the integral of the derivative of that, which is 1 over x. So now we can copy this thing or to this the other side of the equation as it is. However, we gotta write another subtraction for this part. So that's right here, and we gotta include parentheses. So it's just, for this time, it's just AB minus integral of ADB. Yeah. Which is what we have here. And remember, we gotta have 1 and e for each of these terms in the integration by parts. So now what we do is that we just substitute and integrate the simple function and then combine like terms, and we will end up with the final answer. So here I substituted and subtracted here to obtain this part, and then I obtained this part and wrote them within this parentheses here, and do all the simplification steps, and you will get this answer too. You don't have to write it in the parentheses form. You can just have e squared over 4 minus 1 over 4. That's okay too. Right. So now we move on to part C. So part C is let this integral in equals to this thing. Remember, now the little difference is that this is x to the power of 2. However, originally it's just x to the power of 1. So that's something to not forget. N is just a natural number, and we want to find what is the integral when n equals 0. So that should be pretty straightforward, because ln x to the 0 is just times 1, right? So it's x squared times 1, and that's a really simple integral to evaluate, and we end up with this, and we substitute and simplify, you will have this in the end. Part 2 will be a bit more harder, so we want to show. So show requires a full process, like left hand side the equal to right hand side, right? So that's show. And we have to show that in equals to this thing. This thing looks like something subtracting another thing, right? So it's probably integration by parts we need to do to achieve this. And also, since the previous one used integration by parts, so you could probably guess that this one also involves the skill. So for the function in here, I let x squared equals to du over dx, it's algebraic, and I let ln x to the n be be the v. So it's the same Eilate rule as before, and we have dv over dx as this by taking the derivative, and we have u as the integral of x squared. So now we can rewrite in into, again, uv minus the integral of u dv, right? So again, we are having 1 and e, like the definite integrals again for both of them, and then after you substitute 1 and e in here and do the subtraction, you will end up with this first. So you already see that you are approaching this. You already have half of this already. So you want to somehow get the other part, like 1 over 3 times negative n of n minus 1, right? So you want to get that part. So again, you can simplify this part a little bit. You can get rid of some of the x and stuff and just make it simple, and then you will notice that if you pull out n over 3, you will end up with this, and this looks just like the original thing with n minus 1. So now we have I of n minus 1, in here and times some kind of factor. So in the end, we will be able to just pull out 1 over 3, and we will be getting the one the question is asking for. So this full question so far is mainly about integration by parts and knowing how to algebraically manipulate something to make it look like what the question want you to see. Sorry, what the question want you to show. So now we have C3 and D. So now we want to find I1, I2, I3, and by that you can tell this question is more like a tons of calculations, and it's not as hard as before. It's just that you need to be careful. So I1 is just so you don't have to like do the entire integration thing, right? You can just take advantage of this formula, substitute stuff, and get I1 and the I2, I3, right? So starting with I1, you just have 1 over 3 parentheses e to the 3 minus, so 1 equals n, so that's 1 times I1 minus 1 is I0. So you just substitute I0 in there, and you find the integral of that, which is a simple one, and then you substitute and simplify, and you end up with this. The answer key shows something like it has 1 over 9 and then 2e cubed plus 1. You don't have to write it in this form. I don't prefer it in this form because you are still calculating I2 and I3. So you want to keep them as the standalone fractions, so you don't have to do a tons of more multiplications, right? A tons of more parentheses. So now it's getting repetitive, and we are just doing I2, and here we just so I2 is here, and we just use I1 here, and just make sure your previous ones are calculated correctly so you don't have error carry forward, right? So and I3 follows the same process, and you will get these 3 answers. Yeah, it's just very numerical calculations, just basic arithmetic. And at last we have the region R. So it's just the same thing, this kind of a triangular region. We have that rotated 360 degrees around the x-axis, gladly not the y-axis because that will be annoying. And so now we just need to find the volume of the solid of revolution, right? So remember the formula is just pi times AB, and then we have a function, like function, let's say it's x, right? X squared, and then dx. Right, this is like just like the normal pi, and a to b, like it, I treat it like as like something like the height from a to b, like ba, this is like kind of like the height, and x squared is kind of like r squared to me. So it's kind of like a very abstract way of calculating something that if you look at it in this sense, it might look like a cylinder. However, since so it's not a cylinder, but it's mimicking a cylinder. So this formula is just that since you're doing this like infinitesimally, like you're doing like it little by little, you are compiling them, and then each time the R value changes. So in the end, you're just like adding these layer by layer, and you are forming some kind of like a weird 3D shape. Sorry, a weird 3D volume, and then you will just get it, right? So that's how I understand the formula. Yeah, just a quick like reminder. So now just substitute that in there, right? So like, and remember you gotta square this, so it's x squared times ln x to the 4. Looking at this directly, you might be thinking about integration by parts. However, you see that this is to the power of 4, right? It's gonna be really complicated if you do integration by parts, because even this one, without squaring anything, we already did integration by parts twice, right? So we want to have a simpler way to do this without doing integration by parts like 4 times or something. So by observing this, I think this probably reminds you of something that we did recently, right? So we have same thing, integral from 1 to e x squared ln x to the 4, right? So that means this is actually I4. So we just need to find I4. How do we do that? We use I3. So we have just pi times I4 here, right? And we just use I3 to calculate it, and remember to multiply it with pi in the end, and you just follow the same process as C3, and then in the end you will just get this final answer. Yeah, units cubed. So yeah, that's the full 18-mark question. That's kind of challenging on Religion Village. Thank you.